Hello, in this video, we show the emergent behavior of the robot under stochasticity for tic-tac-toe example in the paper. Recall that the reactive approach can only model strategic agents, while the probabilistic approach allows us to incorporate stochasticity, but does not view the human as a strategic agent. Stochastic game allows us to borrow the best of both approaches. It allows us to model strategic agents with stochastic action outcomes. For our experiment, we consider two specifications, one where the robot is trying to maximize its probability of success, and the second specification is to minimize humans' probability of success. Further, there is 5% probability of failure for each player. Note that the player cannot misplace the markers in already occupied location or outside of the cells. We consider three scenarios for each specification. First, without any uncertainty for both the players. Next, uncertainty for either the robot or the human player. First, let's consider the emergent behavior without any stochasticity. The optimal strategy for the robot is to place the marker in the middle. This reduces the chances of failure for future robot actions, as you can see. Finally, the game ends up in robot not winning. Next, we consider rollout with robot action stochasticity. Initially, the robot wants to place the marker in the middle, but instead places it at the top. Notice how the robot places marker near occupied cells. Next, the robot chooses an action where there is non-zero probability of robot winning if the human fails to successfully place its marker on the bottom left, which is not the case here. Finally, let us consider a robot rollout with human action stochasticity. Here, human misplaces the marker in the initial action. Instead of placing it on the top left, the human places it in the middle, as you can see. The robot views this as an erratic behavior and continues to treat as a human as a strategic agent and wins the game eventually. For the second specification, the emergent behavior for the robot is to place its marker strategically and away from human marker, as this maximizes humans' probability of failure. The behavior is same when there is no stochasticity. Now let us consider a rollout with stochasticity in robot actions. There is uncertainty in the first and second robot action. Instead of placing in the middle, the robot places it in the top and on the left. Eventually, as you can see, the robot ends up losing this game. Finally, let us consider the stochasticity in human actions. Instead of placing on the top left, the human places it in the middle. Next, the human will choose an action where there is a non-zero probability of human winning if the robot fails to successfully place its marker on the bottom. Thank you.